had a real bad accident. I had to change the path. Yeah, I went off a roof and messed up my leg and back. Some walls will put it in as actually 2x6 walls, or they're 6 inches wide.
Oh, no.
Well, nobody builds a 6-inch wide wall. The problem we run into very, very, very often is a lot of drafters that are kind of new at it think that outside of that attic room, there's space. You may have a 15-foot bonus room, but then you have these knee walls that come down, and there's webbing in that.
Welcome to Not a Licensed Architect, the podcast for residential designers out there doing the real work without the license, and sometimes without the credit. I'm your host, Stephanie Thatcher, and if you've ever felt like you should be licensed to be taken seriously, but you're still showing up every day, designing real homes that real people actually live in, this is the show for you. Here, we get honest about the struggles, but even more importantly, we're talking about solutions, better floor plans, smarter business moves, and the confidence to finally own your role in the residential construction industry. So if you're ready to level up, lead your clients like the pro that you are, and finally own the fact that you don't need a license to design incredible homes, this is the podcast you've been looking for. Let's go. Thanks for being here today and joining me. I've got my favorite truss engineer, Ron Anderson.
Thank you.
With me today. So you and I go back, oh my gosh, 20 years.
Yeah, about 20 years. Yeah. Long time.
Holy cow. I know, I kind of forget that I've been doing this for that long, but
yeah,
it's been a while. So
yep.
Tell us a little bit more about you and how you came into the career, the job that you have right now.
Well, I've been in construction almost my entire life. Started out in cabinets when I was really young and went to college, and that didn't work out the way I wanted. So I kind of got back into construction again. And then I've worked in about every area of construction that there is.
Really?
Yeah, pretty well. Cabinets to framing, excavation, the whole way up. And kind of, I guess just over 25 years ago, I had a real bad accident. I had to kind of change the path. Couldn't be out in the field as much. So that's kind of when I got into the trusses.
I did not know that.
Yeah. I went off a roof and messed up my leg and back. And so anyway, kind of got into trusses, and I've been doing that for, just over 20 or 25 years.
Dude, so man, when we first started working together, you hadn't been doing it for crazy long.
That's pretty new. Yeah. I mean, because, yeah.
You were so pro even back then.
Well, kind of faked my way through it, I guess.
You taught me things.
Well,
so clear back then. So that was awesome.
Yeah. So it's been a fun journey.
Okay. So what's your favorite part of the job?
Right now, I'd say honestly, trusses. I mean, I enjoyed cabinet work. I did that for a lot of years. Did 14 years of finish work. But I really do enjoy trusses. It's kind of gets my creative side of things going. And
you are the most creative truss some of the stuff you've done for me. Woo.
Yeah, you've given me some tricky ones, that's for sure, over the years.
Yeah. Well, I've had some design assistants who promised things. Do you remember some of them where it's let's have this open 2-story ceiling in a kind of an attic truss 2-story house?
Uh-huh.
And I'm like, can't do that.
Can't do that. Certain things you can't do.
Ron figured it out. Just took some interior bearing walls, no big deal.
Yeah.
Well, cool. All right. Well, okay. So whenever you and I get talking, mm-hmm. You are always really, really good at giving me good feedback on my floor plans.
Okay.
And telling me what things you like to see. So I don't know if you have a list that you keep handy in your back pocket.
Well, I've got to definitely have a list. We see a lot of different plans. Do you want me to go through a few things, I guess?
Yeah, totally. So let's hear the good stuff. We see a lot
of plans, from great ones to absolute not horrible ones.
Total garbage.
So the biggest thing for us doing trusses is we need to have a clear plan with dimensions on it, wall heights, stuff like that. So we know exactly what people are trying to accomplish.
Wall heights. I think that there's a lot of like drafters will, and maybe I shouldn't point fingers, but there's a lot of people who produce floor plans who might not think that a truss guy would need to know wall heights.
Yeah, but it happens all the time. And I've actually had plans where they've given me, rather than a wall height, they give me a fascia line height. Well, that's fine, but I don't know what kind of overhang you're going to have or heel height. That does me no good.
Gotcha.
And so good plans, like I say, I deal a lot with architects, and I deal a lot with just regular draftspeople. And honestly, architects do a great job. Nothing against them, but they deal with more complex homes or plans sometimes. And so there's a lot of information in there that maybe not be relevant. I mean, maybe relevant to the painters, electricians, and stuff like that. But if it's all in an area where we're trying to look at it from a design perspective, as far as lumber side of things, there's too much information.
Okay, so they need to like kind of break up the plans a little bit.
Yes, it's nice to have, because a lot of times in architectural plans from an actual licensed architect, we'll have like a reflected ceiling plan, and things like that are handy. But a lot of times with a licensed architect, we'll have dimensions to the outside of my sheeting. And so nobody builds to the outside of this sheeting. They build to frame.
Are you serious?
Yeah, all the time. And so we have to make sure we look real close at the plans to make sure the dimensions are not to outside of sheeting, but rather framing. And we can adjust our program to account for that, but it just complicates everything.
But just if you're not aware of that, then you can be off by an inch and a half.
An inch, yeah, depending on the situation, yeah. The other thing is we see, there's a lot of drafting programs out there. Mm-hmm. And some of them, and I think, I don't know, but I think it's in the setup when they put up their wall systems. But some walls will put it in as actually 2x6 walls, or they're 6 inches wide.
Oh, no.
Well, nobody builds a 6-inch wide wall.
Well, yeah, that's okay.
And so we'll go through all the dimensions, and none of the dimensions work 100% because they've used a 6-inch wall when it's actually a 5.5-inch wall. The other one we see a lot that's really confusing is they'll have outside dimensions to center of walls. And nobody builds the center of a wall. They're always going to one side or the other.
Like, I guess I need to dig in as to where center of wall dimensions even originated, because it makes zero sense to
me. It makes no sense to me either. And so
like not even to the interior walls. Yeah, like nobody wants to do that mental math.
No. And so dimensions for me is probably one of my key things.
Okay, dimensions.
That's like number one, because if we don't have dimensions, we have to try to scale it. And sometimes the plans we get a copy of a copy that's been photocopied and nothing's to scale. And, we have programs we can import them and try to scale them, but they're not always very accurate.
Okay, what's your favorite file type if you can import?
Well, I use Bluebeam, and I can take and resize things as long as the PDF's a good PDF.
Okay, yeah.
I don't use a lot of DXF files. I know I send a lot of DXF or DWG files out. Mm-hmm. But for me, I prefer having just a regular PDF. And I'll be perfectly honest with you, yours, and maybe I'm sure maybe his name, but Curtis's plans, you guys, and it's because of where you came from, the plans are really good, and so when I see one of your plans or Curtis's plans, it's like, I'm happy to work on, because I know I'm going to have everything I need to know is on that plan.
Okay.
And so that helps me a ton.
Well, that's a huge compliment to me. So thank you. But I would like spin it back to like, it's because of people like you who give me feedback. Yeah. I'm always looking for where are the holes in my plans. And that's why I'm doing this, right? Yeah. You've got to find the holes and plug them. And so for you, my question is, if you've got really good dimensioned plans, how does that equate to like field measurements? Because I know that a lot of times when you actually like order the trusses, they go out and do field measurements where they measure, the foundation outside of foundation or wherever it needs to go, whatever. So which one takes priority at that point? Field measurements, probably?
Well, yes, depending on the field measurements, but a lot of times I have one person I deal with particularly. He draws his own plans. He's a great builder, but he draws his own plans. And we'll get a dimension that'll say, rather than, say 10-foot half inch, it'll say 10 foot and 7/16.
No.
Or
I knew
something
you
in
were going to say
15,
something.
15/16 or 22/32. So that doesn't do us much good. And so, and we just deal with it and get through it over time. But, if we have good plans that aren't really dimensioned bad, it makes it easier for the foundation guys when they're putting in footings. And when the foundation guys are snapping lines to put their line, it just makes it all the way through the entire build process to go up a more straight house. I just came from a house today, and it was an angled house. And angled houses are typical for being out of square.
Oh, for sure.
And it doesn't take, you get a garage on a 25 or 30, 15 degree angle, whatever angle it is. It doesn't have to be out very far before it's out a long ways. I mean, if you're off a quarter of an inch, by a quarter inch over 20 feet's a long ways.
Yeah.
The house was beautifully done. Perfect. So we don't see those a lot. That's good though.
Yeah, I've got an angled house right now. So you're making me remember, like, as I'm wrapping it up, I need to be sure to get, I don't always, because I forget. It's so at the end, but I like to do a dimension, like I create a square rectangle so that it can be, so that any foundation guy could pull his cross dimensions, like crisscross, right? And be able to know that his foundation forms are square.
Right. Yep. That's perfect. That's what I did with this one today. Is I measured from some long angle points to my angles where the garage angled, so I can use that as a reference to make sure that when I tweak the garage trusses, that they are actually going to fit exactly the way the garage is built.
Yeah.
The foundation's in. So
yeah, I'm not going to lie. There's been a house that I designed that got built, and I went to do a site visit, and the builder was there, and he was telling me about how horrible of a job his framer did. And and there's like all this finger pointing happening and stuff. And I'm just sitting there thinking, because what happened was, like, this wall was this high, and the wall, like in a garage, one side of the garage was this high and the other side was a different height. And I'm like, who even does that? A, the framer, and B, like the general contractor. And I was so shocked and stunned. I just couldn't even believe. And they were showing me all these problems. And I did mention, like, I'm pretty sure that the plan has like the cross dimensions across the foundation. Like, did you check those? And they kind of acted a little bit like deer in the headlights, kind of like, I don't know what you're talking about.
Like, we checked that.
I'm like, I think if you had double checked, or the foundation guys or whoever, bless their hearts, those foundation guys, they've got it, like working.
The rough one.
Yeah, that rough end stuff for sure. Okay, so we've got dimensions and wall heights. What else? I mean, like, let's just name the obvious stuff.
Snow load is a huge issue for us.
So how do we calculate that?
Well, the state of Utah and Idaho both have kind of like a state website you can go to figure out what the ground snow load is. And then from the ground snow load, you can calculate the roof snow load. Problem is that isn't always accepted by either a city or a county or whatever. And on top of that, there's one area I build in Idaho where in just the one city alone, they have like 4 or 5 different snow loads. And so we have to, because it's up by Island Park. And so there's a lot of different varying elevations and snow conditions. And so, with those kind of stuff, I had one recently where they gave me a snow load of 78 pounds. One I know for a fact that it's got to be 128 pounds of snow.
Oh, interesting.
And so even though the structural engineer said 75, I knew that was wrong.
Okay, so what does that do? Like, what if there's a larger load, then what do you have to do on your
the biggest thing we have to deal with is anything over 50 pounds of snow, we have to increase what are called our DOLs, or our duration of load. So what that's referring to is how long the snow will sit on a roof.
Oh, okay.
And so we're allowed to take in some areas under 50 pounds of snow load, we're allowed to take a 15% reduction in our DOLs because the snow melts off quicker.
Okay.
In those higher snow elevation areas, the snow stays longer.
So do you have to add more webbing?
Yeah, more webbing, change the grades of lumber, the plates. There's a lot of factors that go into it. So we just say, okay, we need to have this DOL at 1.0, and then our computer program will calculate, okay, this is what we have to do to accommodate that.
Can we, as those who are producing the floor plans, can we do anything that helps you with that?
If it's on our plans, the one thing I will say is not every county or city requires a structural engineer, but I under no circumstance will I build any building of any consequence without hiring a structural engineer.
I agree.
It's just there's too many things that can go wrong. We have all these snow things that went, about 2 years ago, we had that really heavy winter, and we had a lot of buildings go down. Yeah. Only a couple were houses. Most of them were barns and stuff that have been in place for a long time. But having a structural engineer to look at it is paramount, in my opinion.
Yeah.
And then you have to, as a designer or an architect, somebody needs to verify, yes, this is a sufficient snow load for this area.
Yeah. Yeah.
We ask all the time.
Okay, so I'm going to just broaden this a little bit because we are, we're so used to our climate and our conditions and different things like that, our ground and whatever. But and I know that you and I can't speak probably too much to coastal areas and stuff like that, where they have high winds and, flooding and different things like that. So they will have different loads and different factors that will weigh in on their projects. But I feel like the same kind of standards apply, where it's just have a professional who is calculating snow loads, or sorry, not just loads, but all the forces. So different forces on the structure, and can certify or validate that what has been designed is structurally sound. That's super interesting, because I work really closely with some of what I consider some of the best roofers in the industry in our area, and just understanding how roofs drain. My sister right now, probably as we speak, she lives in Northern California, and her roof is so simple. It's literally one ridge line. It drops. There's one jog in it, and it drops the ridge line over this spot where the section that has the dropped ridge line, they want to add a front porch with a gable. And I know it's really hard to describe, but anyway, I'm looking at it and I'm freaking out, because I'm you're going to add this gable over the drop section, but it kind of comes out over the regular main section too. So you've got this weird valley that's going to jog, and it's going to hit the sidewall of the gable. And I'm just freaking out on her. and I'm I know it's probably just me being where I'm located. Maybe where she lives, it's not a big deal. They don't have snow to deal with, and they don't get a lot of rain. So maybe it's not a deal.
Well, I think in all the areas in particular, each area has their own specific things you got to watch for. Years ago, I spent some time working in California, and seismic loads down there are paramount.
Right.
And where we are, typically our wind speeds are calculated at what's called 115C, the category C, 115 miles an hour, category C.
That's pretty high for here.
But that's pretty high. But yet, you go right over the hill on the Wasatch Front through the Bountiful Farmington area, and you've got to go to 100, I think it's 150 pounds or wind speed.
Right. So
if you're not aware of that, so we have to kind of know those kind of things and where the house is going. And I'll be honest with you, I've done that once where I had the wrong wind speed.
So, man, that's that's all a little bit outside of our bounds. That's where we're grateful to have structural engineers, because I know that there's those factors, and I love getting feedback from the experts, but I have not been trained or educated in how to calculate any of those forces.
Right.
So just like you're saying, it's good to have that person who is licensed or capable of looking at that. Okay, go back to the basics, because I know we're missing some of like really simple things that you love to see.
We can talk about energy hills and trusses for a minute.
Okay.
So a lot of people are being very energy conscious, and they want energy efficient homes, and so they'll say, "Come to me with an energy truss." Okay, well, what's an energy truss?
What is it? Yeah.
Yeah, and so nobody can define what they just want a taller level of insulation.
When you say nobody, you mean like the homeowners or the builders or whatever? They just know that they want it. They're not sure what it means.
Yeah, they just say I want energy hills. And so a few years back in the valley here in the county, we are going to say we want a mandatory energy hill requirement. I said, okay, well, what's that going to be? And none of the cities could come to any consensus of what they considered as this energy hill. And so
they all had a different opinion.
They all had different values. So a typical roof on a 4 to an 8/12 pitch is going to have about a 4-inch heel. And maybe for those who don't know what a heel is the heel is a portion directly over your external bearing walls. Yeah. Okay. And so you may have a 4-inch heel, which is not bad. But if anything you do above that, with most of the things we've done in the past, we do 7 to 8 inches. And so that's almost doubling the amount of insulation you have in your exterior wall. So that's quite a bit.
Right.
And so typically I will do between a 7 to an 8-inch heel when they ask for an energy efficient truss. And that seems to be the kind of the cutoff between not adding a lot of cost, but yet, almost doubling the amount of insulation.
Okay. I appreciate that you mentioned cost, because we know that there's all kinds of designs, there's engineering that can really like drastically increase costs without adding a lot of real significant benefits. And so I appreciate that you are kind of like walking that line. The other question I have for you is the types of trusses that we typically use here. We have the tails, right, that come off. And so when you raise that heel up, that helps so that, like, let's say we have, like, I've had a crazy, I don't know if you did it or not, but like a 16/12 pitch.
Oh, yes.
And so if that's the case, then we have a really long tail that might, get in the way of the header of the window or something like that. So if we add a little lift onto that heel height, then that helps us to avoid some of that conflict there between the tails, the overhang, the soffit, conflicting with the top of the window.
And when you draw up plans, typically everybody draws up the fascia lines to line up all the way around the house, because that's everybody kind of likes them uniform around the house. But then I personally like a few breakups here and there, especially on an attic over a garage. I like that offset heel. But when you start having 3/12s, 4/12s, 10/12, you have all these different varying pitches in there, then we have to say, So we have to basically adjust our heels to match at a specific overhang.
Right. So when the fascias line up, you're the guy who's calculating the heel height to make it so that hip that's got an 8/12 lines up with the front hip that's got a 6/12. Yeah, you're my guy for that.
Yeah, that's what we have to. So there's a lot of math, and honestly, in high school, I wasn't very good at math, and little did I know I'd be doing lots of math every day.
Does your computer program help with that, though?
Yeah, I mean, but I have to still do tons and tons of more math than I ever dreamed.
And we need a whole course on that.
Yeah, I mean, we're figuring rise, run calculations, and and we they'll have. Well, I don't know what this wall height is going to be. Well, I don't know. Well, you tell me. Well, you figure it out. Yeah. So then we're having to do the math to figure out, okay, we're going to go this far on this run. And then we say, okay, that's going to be your wall height. So we do that very regularly. Where they'll ask us, will you please tell me my wall heights? And we can do that. So
I'm lost.
Because they don't always know. I won't say what project it was, but it's a big project here in the Valley, a real big one, many millions of dollars. And the architect was out of California, and we had a specific heel height we had to know, and he had no idea. He said, I can't even tell you what that wall height is going to be. And so
I'm confused. Like, aren't the walls the thing that determine where the truss is? Like, how does?
Yeah. So they knew what the main level was, but they had some interior wall heights. And so they had
with like some vaults or something.
Yes. So it has some hand framing, some special things that all tie together. And I had those wall heights because I had trusses that matched them specifically.
Or we can talk about those single slope roofs.
Yes.
Right? Where it's just, I've had a house like that where it was really cool. The whole roof was one plane.
Yeah.
And it cut in here and over there, you know, like, but it was planed out all the same. And so you got to like, I knew the plate height here, but yeah, to figure out the plate height of where, so, you know, with that pitch and everything, not to mention each stud along the wall, right?
Yeah, on a rake wall. Yeah. So there's a lot of math that goes in to figure all that out. Yeah.
Yeah. Okay. So how many plans have you ever gotten that don't have the pitch noted or the overhang or the fascia size or anything like that?
How much time have you got? We go on for days. It's honestly, every week we get plans every week. The other thing maybe you can mention about that, we're kind of talking about this, is trays and attics.
Okay.
Trays are kind of, everybody likes trays nowadays.
Well, anything that's built into the truss design.
Yes.
Right? And,
yes.
And I guess I should be really clear that we're talking specifically about truss. You know, we're using trusses here all the time.
Yes.
And I know that there's plenty of other places.
Yeah, they do
all kinds of hand framing, and it doesn't. I mean, there's still all the same calculations that need to go into place, but okay. So yeah, trays.
So let's with trays. I've got one right now I'm working on where it's a 512 pitch. And they want me to outside pitch is a 512 pitch, was fairly shallow. And I've got to come in 2'6" and go up 1 foot. So you start doing the math on that, and my tray is almost coming out the roof.
Because the tray is in a room that's at the edge of
the wall. Mm-hmm. And it's like a primary suite, a master bedroom, which is where everybody wants to put their trays. And so, 15 years ago when we started doing all this, we were working on a lot of people did sloped trays. They were easy to do, but now everybody likes the square trays. So they're a little bit harder. And so that, we almost always have to end up raising the heels to make that, to accommodate them and go to a smaller, rather than a 1 foot tray, we'll go to a 10-inch tray or a 9-inch tray to make it cost effective to work.
Okay.
There's no cost, there's that break or the difference between what's practical and what we can, actually make work.
Right. Yeah.
Go ahead. Yeah. The other issue we run into a lot of times is attic trusses. Attics, bonus room trusses are very popular, and they're a cost efficient way over garages or a house or whatever. The problem we run into very, very, very often is that a lot of drafters that are kind of new at it think that outside of that attic room, there's space. And you may have a 15-foot bonus room, but then you have these knee walls that come down, and there's webbing in the back. They think you can go with their storage back in there, and you can't get in there.
I'm giggling because, so many people, I can't tell you how many times where I've seen other people who've designed we can, and don't get me wrong, there have been times when I'm like, yes, we can do that. There's all this space here. Yeah. And until you think through the structure of it, if you don't know how to imagine the structure, then you could fall into the trap of thinking there's all this room available.
Yeah.
And okay, so here are the things that I learned from you about bonus rooms. Okay. No, they're good. I always try to have the opening into the bonus room right in the middle of that space.
Yes, that definitely helps.
Okay.
Yep.
That's one thing. And I just barely was working.
And if you can, run your stair hole parallel with the trusses.
Yes. So for example, there have been many plans that I've designed where people want to access a bonus room over the garage, but they don't need to access it from inside the house. And so, there's stairs, let's say it's a mother-in-law suite or something like that, or some sort of hangout space or whatever. And people try to design the stairs to be parallel to a wall, but it's perpendicular to the direction the trusses are running. And the reason why, in case people don't know, is because
headroom. You
Yes.
start to go up those stairs and suddenly you're hitting the bottom cord of the truss.
Yep.
And all of a sudden you got to cut that truss off.
Mhm.
It doesn't work.
Yep.
So
and we've been able to make them work, but let's say you cut off 4 feet of it to allow for a staircase, but then they think, well, we can just stop that end of that truss at that point. But we have to have, you may cut off 4 feet, but we have to have some space for some webbing to make the truss actually run.
Well, and you still need a top cord.
Yes.
So at some point you're still gonna the bottom cord is one thing, but you keep going up those stairs and you might hit the top cord.
Oh yeah.
Right.
Yes.
And so to avoid all of that drama, let's just pull a truss out. That's what I try to do. My stairway is 4 feet wide. I mean, just under, right? Because we've got 4 foot on center at that point for the truss spacing, and so just under 4 feet, you can get a nice accommodating staircase that goes right. You skip one truss. There's some ladder framing that the framer has to do, and it's just really straightforward and simple.
Oh yeah.
And so, that's great. So opening, run the stair. I'm glad you mentioned the stairs.
One other thing with attics would be the size of the room.
Yes, that's where I was going next.
Yes. Everybody wants they may have a 40-foot truss. They want a 30-foot room in there.
Yeah, no.
Well, you can't do it. There's the deflection. Well, there's ways around it. You can do a built-in floor truss into it. But we have a rule. I'll tell you the rule is you take the length of the room in inches divided by the bottom cord thickness, and that number cannot exceed 20. So if you were to get a calculator.
Okay, wait. Okay, so let's do this in real time because I have my own way to calculate it. Okay, so let's just say that the length of or the width of the room.
Yep. So pick a room size you want to do.
Let's just go 30 feet, make it a nice even number.
Okay, 30 times 12.
Because that's the height of our bottom cord.
No, so you have 360 inches.
Oh, I see. Okay.
So take the length of the room
I don't
in
think
inches.
in inches. Gotcha.
So 360 inches. Now divide that by the thickness of your bottom cord, which if you do a 2x12 is going to, or 11 7/8 is basically a foot. So divide that by 12.
So you're back to 30.
And you get what, 30? Yeah. See, you can't exceed 20. So what's going to happen is that when you're in that room, you're going to feel like you're in a trampoline. So that means that bottom cord has got to go thicker. So
wait, so that would be 30 minus the 10 equals 20.
No, do 30. So do 30. So do the the 360 divided by 12. Okay, and that number cannot exceed 20. So that means that you're at 30.
Oh,
so that deflection on that truss is way past the limits of that can be designed, and so you'd have to do something in the order of a 24-inch bottom cord. So let's do 360 divided by 24 inches. That gets you 15. Okay. So that room there would be a built-in bottom cord truss. You could do it. It's a little more cost, but then your floor will be satisfactory to the homeowner.
We should test another one with the way that I do it.
Okay.
Because we'll test my calculation and see if it fits always your calculation. Okay. So mine is take the width of the span.
Okay.
So your span dimension, divide it in half.
Okay. So what's your span?
So let's just do that same 30 feet is your span. I would say that your available room space is only 15 feet. 15.
Okay. Yeah. So 15 times 12 divided by 12 is 15 again. So yeah, that is anything over. I've done 18, but 18 is kind of where you're starting to get, I think, a little bit bouncy.
Yeah.
And so, if you have that over a bearing point in a house or something like that, that'll change it because you got a mid-span bearing.
Yeah, so you could add a post with a beam or something.
Yes, and that'll help
across there. Yeah, so there's.
But most times bonus room trusses are over garages where there is no internal bearings. They want free-span bearings. And
I mean, even if it's over a house, over the main floor and the second floor, is. You're typically burying those trusses on the external walls and not counting any interior bearing walls where we live. I know that that's not always the case, in other parts of the country and the world and whatever, but for us. So let's take another number really quickly just to see. Go 40 foot width for my span.
Okay.
That means I wouldn't do a room. I wouldn't estimate that the room size would be any bigger than 20 feet.
Okay. So if you do 20 feet.
Okay. So why are you using you're using the room size that people want?
Yeah. Because you're saying you want a 20-foot room in it. What you're thinking you would have. So 20 times 12.
Okay.
Is 240 inches.
Okay.
Okay. So divide that by 12 and you're 20. So you're right on the edge.
Yeah. Okay.
So, yep.
Okay.
Now, one more thing along with that. So it's easy to say, well, let's just raise the bottom cord up. No big deal. Let's do built-in bottom or built-in floor trusses in the attic trusses. Yeah. Well, now you've just raised that. Typically I'll go to 18 inches. So now you've just raised your bottom cord 18 inches. Mm-hmm. So now your floor, if you're on a second floor house, you can't walk in that you're off by 6
inches. You have to step up.
So you either have to start doing floor trusses on the upper floor or lower walls or get a stair. And then the other issue we run into from a design perspective on your side is, okay, now you've gone up an extra 6 inches. Now you need some more run for your staircase. So now will your staircases actually fit? Now, on a big home, usually you can make it work.
Right.
On an entry-level home, they're designed in such a way that typically you don't have enough room. You can't get one more step.
Well, I just this year I designed a home that it was a 2-story home. So there were other rooms above the main floor layout. And then the rest there were 2 bedrooms that they wanted over the garage. And so it was like a hallway from the main second floor that went over to there. And between me and my assistant, we kept getting ourselves confused about what does the garage wall height need to be? What does our bottom cord need to be? And we were trying to match our bottom cord to match whatever we were using for the second floor system. So if it was an 11 7/8 inch joist, we were trying to just kind of match that. So that it was just, but there were times when we were just our brains were getting fried, just trying to make sure that we were doing the calculations right, that there wasn't a weird, we've got to step up or it steps down or whatever. And there have been plenty of bonus rooms that I've designed where we did have to step up or step down because of whatever it was, giving us the headroom or what they wanted in the space below, or, just the differences there. So that is super important. So on my plans, I have an amazing design assistant who helps me. And I'm sure you've started seeing some of them, but in the last, year or two, we've been doing a separate drawing on our roof framing page. So we have a roof framing page, and we recognize that our roof framing page is not it's not telling the actual roof framing. It's just giving you an idea of what we have designed.
What you're kind of thinking.
Yeah. So it's just kind of one step towards getting an actual roof framing plan, right? Helping the structural engineer, helping the framer, helping the builder. We know it's not exact, and we say, please refer to the Truss guys, But we have the roof framing plan. It just shows kind of general, this is overbuild, this is gable, blah, blah, blah. We have another part that shows the plan view. So roof plan view that shows ridges, valleys, whatever. And we label pitches and different things on that. But we also have a third one now that is basically the roof plan view, but then we do hatch, area in it for the ceiling heights.
Yes.
So that you can see from a truss guy's perspective, underneath this roof, I've got a vaulted ceiling here, and I have a 12-foot ceiling, because that's something that I've really leaned into heavily since I've gone out on my own. Is instead of necessarily having so many people did vaults back in the day, and I keep telling my clients a vault is great, but it doesn't get you bigger windows.
Right.
And so let's raise the wall. And if we can get that raised kind of like ceiling height, if we can go from like a 9-foot to a 12-foot in the middle of the house, we can kind of build it into the trusses.
Yeah.
And so in order for us to be able to, give you all the information in all the different ways so that you know what's happening, we've included that ceiling.
That helps a lot.
Kind of like diagram.
Yep. Yeah, that helps a lot. Having some kind of note somewhere on the plan specifying, an entry height, a great room height. So that helps tremendously on our.
Okay, so yeah, we also label our, we don't necessarily always label like our wall heights. We try to if there's a variation. And of course, we've got dimensions on our elevations that show plate heights for different things. Doesn't always but that doesn't tell you what's happening in the inside.
Correct.
Right? So what we have to do on the inside is inside each room label, like this has a 12-foot ceiling and it's vaulted. And we try to even specify that like, oh, this is the other thing you taught me, that like vaults, typically I try to keep vaults no greater than like the maximum I'll go on the vault pitch is half or less of the roof pitch.
Yeah, that's pretty common. Yeah.
Yeah, but but here's the thing, Ron. You say it's common, but nobody taught me that. You did.
Oh.
Like I didn't learn that in school. I didn't learn it from the builders that I worked for. Like if you hadn't told me that, I don't know where I would have learned that.
Oh, well, I'm glad you've learned it.
I know, right? Yeah. But how do other people like, who want to do the work I do, how do they learn that?
Well, trial and error, maybe, I guess, watch the podcast.
Yep, listen to the podcast.
Because I know, and we definitely do times where we have steeper pitches like that on the inside. But we have to do things to the trusses. Once again, back to the heels. Special. Yeah, we got to raise the heels to accommodate that kind of,
Or it gets hand framed.
Yeah, our hand frame. And that's along with that, we're doing a lot of stuff over the hill by the lake where people want parallel chord looks for big trapezoid windows looking out over the lake. But they don't want to spend the time, hand framing is very expensive. And so we found ways to do parallel chord trusses to a ridge beam.
Okay.
And that's worked out really, really well. It's much, much faster.
I actually have a project that I designed this year that they wanted a vault in their great room. It is over at Bear Lake.
Yeah.
To be able to get the big windows, nice big vault, but it's vaulted outside too, like over their deck. And I was trying to, I was talking to the clients about we can do the parallel chord truss design, and that will look better than the scissor truss.
Right.
But the scissor truss is so much less expensive.
Yes, it is quite
right.
Expensive. Yeah.
So they opted for the scissor truss, and it looks fine. But
they look good.
There are those things. So you can basically take what you're saying when we talk about a parallel cord truss. We're talking about basically like taking a floor truss and turning it into your roof.
But yes, and usually we only do just one side. If it's a short span, we can do a true parallel cord up and down, but we have height restrictions for shipping down the roads.
Exactly.
And so we, if you have a long span, we can't do it. So typically we'll do those. Well, they'll actually still have a ridge beam, and a lot of those kind of homes want that look of an exposed beam. And so it works real well. We just make the truss to hang off the beam, and they look like eye joists basically, but they're a little bit wider. Usually 16 inches rather than 12 inches is the max we can do.
Is the max? The minimum.
The minimum. Okay. So that works out real well, though, because you have the open webbing, and so they can run, rather than eye joists that have to have holes knocked through them for wiring and stuff like that, with a regular parallel cord truss, you can run your electrical wires through them.
Right.
Run 2-foot centers rather than 16-inch centers. So there's a lot of benefits to them.
So let's just go, and we'll just kind of like let this be the capstone of this conversation.
Okay.
Speaking of trusses like that or roof designs, when the modern design has really come on strong, and it started really coming around right as I was transitioning from being an employee to being self-employed. And so I didn't have, again, any real great experience or education around what it took to design a modern roof. And to be honest, some of the first things that I did, I was still thinking like 2x4 pieces of lumber in my head when I should have been thinking like a floor joist or floor truss. And so a lot of times when I design more of those single slope or modern roof styles, I am designing with either like a 14-inch floor joist or coming to you and looking to have a floor truss designed to be used in that application. Do you design it differently if it's going to be on, like if it's going to have an angle to it, because your webbing, it gets different, right? You can't have the webbing be like this.
It's
got to be vertical. Okay. So you still need to know the pitch. For sure on that. Okay.
Definitely have to know the pitch. That all comes into play. For sure.
Any other tips or advice that you would give us when it comes to those kinds of roofs or using a floor truss for a roof's application?
No, not I can think of. One thing it may come in handy is obviously hip roofs are definitely more expensive than gable roofs. And people don't understand why, but the complexity from a truss perspective to build the truss.
You can't just swing them up and
from the manufacturing, every truss has got to be set up and built, each individual one, versus say, you have 10 common trusses, you build one, you set up one and build all 10.
It's more like a puzzle that you have to put together. You deliver in your package, like this is truss A, B, C, D, whatever, however you enumerate it, so that when the framer comes in, they know they've got to get this truss and it needs to go here. Okay, so with that, you keep reminding me of things. Like, I didn't know what a girder truss was, to be honest, when I first started designing homes. Like, again, I learned how to draft, but I didn't learn about all the little, like nuanced things. I knew headers and I knew, sill plates and all that kind of lingo, but somehow I missed girder truss along the way. I don't know if I just missed that class or if they weren't teaching it, but to know what a girder truss is and can do is massively helpful. And so when you're talking about hipped roofs, there's a lot of girder trusses in there. Because that's what your mono trusses are going to be kind of like resting on or hanging on or whatever, right? That's something I learned, again, from working with you. You were really great to always give me feedback and to know, and so a girder truss, if you've got a girder truss in the way of a tray ceiling, for example, does that complicate things?
Someone as we speak. And it's like, once again, low pitch, 1 inch, 1 foot tray. It's a 50-foot span, no internal bearing, and they want a 12-inch tray in it. So it's like, well, this is going to be complicated.
On what pitch? A 4?
A 5.
A 5.
But that's a big span. But we'll figure it out. It's just time and money. But
exactly.
Girders get expensive. Anytime you have a truss carrying other trusses like that, they can. There's a lot of loads. And they just have to, they have to be designed to carry kind of the worst case scenario. And so,
So when I'm designing and trying to think through the structure of the roof, I'm looking at and I just usually will say it in my head, roof beam, but a lot of times a roof beam can be a girder truss.
Yeah, correct.
And so, I'm doing one right now. Hopefully you get it. But, we've got some areas where the trusses will need to be stubbed off because of ceiling height differences. But there's also, as you transition from for example, a gable off of a hipped edge of a lot of times that will have a girder truss on the back side of it, right? Bonus rooms have girder trusses in them. Dormers for sure are flanked by girder trusses. hipped roofs have girder trusses in them at some point in off of the perpendicular hip. Where else? Can you tell us?
Active dormers have them.
Yeah. Yep.
I don't know. We kind of hit, all the gables will have them a lot of times, depending. Nobody builds a straight, 30 by 40 rambler anymore. They're all complicated.
Oh, you're saying we like our jogs?
Yeah. So I mean, it's funny because I see houses. I did one yesterday that has got girders coming out of everywhere. They're absolutely, and it's a very, very, very expensive roof. But yet I've got other houses. I've got one now that's probably a $2-3 million house, but it's designed in such a way that it's all boxes. And so it's gable to gable, and there's almost no girders, and there's almost no hangers. And so it's like, well, listen, even though it's a huge house, the roof part of it is quite inexpensive compared to the other house.
Okay, you're hitting on like key topics that I mentioned in my course. Okay, so number one is I talk about the importance of aligning exterior walls.
Yeah.
So a house I'm wrapping up right now today, working on trying to get it delivered. But like the back bearing point for the roof is aligned. And we're talking a 4,500 square foot main floor.
Okay. Yeah.
So this is a big house.
Yeah.
And so, but that back main bearing point from left to right is lined up. There's jogs out of it. But it's lined up.
Yeah.
And like from front to back and stuff, there's things that are aligned there to just make your life simpler, the framer's life easier, those different things. And then, oh gosh, I'm going to forget what you said, but there were some other things that you mentioned there too. Just, using boxes. So when I'm first starting my design, I'm thinking already, like right at the very beginning, I'm thinking ahead to the roof. And I'm trying to set the footprint and the design so that it can take a box set of trusses. And so it can just go right out.
Yep. That's awesome. That helps through the entire build process from foundation to the roof. That makes everybody's life easier, which translates to a less expensive home.
Less expensive. You can have a bigger home, but if it's easier to build, then it doesn't have to be crazy expensive.
Yep.
So I love that you illustrated that by saying, you're working on a big, huge house right now and the roof is easy. Even though it's complicated, it's easy.
I mean, it's just, when you look at it, you want to just cry because it looks super complicated. And I mean, it's huge. But like I say, the roof goes together quite simply because just the way it's designed.
Okay. Was it an architect or a designer?
I don't know. It may be one of yours, actually.
Oh, let's test it out.
I'll look. I won't mention any names, but I'll just look real quick.
We don't need to mention names.
Whenever I see yours, that's like, oh, great. It's one of Stephanie's. I'm happy. So
I'm glad you can say happy. Because I'm pretty sure I've made you cry sometimes.
Oh, man. Let's see real quick here. Where is that? I mean, it's a huge house.
I'm trying to think of huge homes that I've done recently, but
no, but you know who did it. You know who I'm talking about.
Okay. Gotcha.
Yeah. So he do it. So I know it's gonna work.
Okay, cool.
Because you guys work together forever. And so when I see his plans or I see your plans, they look so much the same that it's like I can tell you guys work together because it's like and the other thing is I look at it, it's like, okay, it'll work. And that's the thing, because I know that enough time to put together in designing this roof or the plan that I'm not going to have a bunch of problems. Right. That it's going to work. It may be complicated, but it's going to work.
Okay.
That makes my life and everybody's in the build process life a lot easier.
Yeah, that's the thing. If we can reduce the amount of stress and like going back and problems and whatever in the field, because we've thought through like these alignment things and what are the products that they're building with and how can we design to fit the products, even if it's like even if it's a custom truss, we're still trying to design to fit how you design trusses, you know what I mean? And so that's super helpful. I'm always grateful for the feedback that you give.
Well, I appreciate that. You're awesome to work with.
It's been really amazing over the years to learn and grow from you.
Well, you've done good.
Appreciate it.
So,
you're awesome.
Okay.
Thanks again for being here.
You're glad I could be here.
Okay, we should tell people where you work at least. I know you don't have socials and stuff like that. You're not a social media guy, right?
No, not well. I do a little bit,
not for work.
Yeah, I mean, can I go and tell them where I work?
Yeah.
I work at SunPro.
Okay.
Part of the Clyde company's been there for 15 years. Great company. So yeah, love to help anybody else we can.
Okay.
Stephanie does a great job with your plans. So
thank you so much, Ron.
Okay,
we'll have to do this again another time. I appreciate
all right,
it.
sounds good. Thank you.
Okay, take care. Bye.
Bye.
Thanks for hanging out with me on Not a Licensed Architect. If you're ready to stop second guessing yourself and start owning your place in this industry, make sure to follow the show and share it with another designer who needs to hear it too. And if you want more real strategies and floor plan tips you can actually use, head on over to dostudios.co for more courses and resources to supercharge your residential design career. Remember, you don't need a license to design a home or a life you're proud of. Thanks for hanging out. We'll catch you next time.